Welcome back to the LeetCode challenge. Today we are going to solve rearrange array elements by sign. We are given an array columns which have even lengths, consisting of an equal number of positive and negative integers. And then we are asked to rearrange this array by the signs. There are three conditions of the rearrange rule. The first is every consecutive pair of integers have opposite signs. It means that one negative comes after one positive, and then alternatively. And the second rule is for all integers with the same sign, the order should be preserved. It means, for example, in this test case, the positive sign, we focus on the positive sign. After rearrange in the positive negative order, the positive order should be remain. So does the negative one. And then the third one asks us to start from the positive integers. Notice that there are some constraints of the test case. Then they said the numbers I, the absolute value of nums I, should be greater or equal than 1. It means we won't met 0. Okay, let's look at some ideas. The first idea comes to my mind is, why not just storing the positive and negative integers separately? For example, we store the positive ones in A and the negative one in B. And we only need to go through the array once, so we can create this two array, preserving the order of each sign. And then we use two array to create the array we want to return. We go through, I will take one element from here and one element from here, and then so on. And this way we can preserve the order and will reach the opposite sign of consecutive pair. The runtime is OM because we just go through the array once and then the second time here, so it's still OM. In terms of memory, we have OM because we store list and numbers into two arrays. However, is it necessary to use additional memory to store the positive and negative numbers? Can we do something like, for example, when we go through the array and we miss some positive number and negative number, we write it in an array, and then for the positive one, we go find the next positive. Similar thing applied to the negative one, we find the next negative one, and then so on. In this way, we don't need additional memory or maybe just constant, but we can achieve the same thing. So it's more efficient in terms of memory. To achieve this, we use two pointer string. We use one pointer called P for positive number and N for negative number. And to initialize, we go through the array and we mark the first positive and the first negative number. And then we write down 1 and we write it here. 1 and -3. And in the second iteration, the P moves on to the next positive number. So this N to the next negative number. And then we write down 2, -1. And so on, it will move here to here. And the negative 1 just moved to -2. So We just write it down. Then problem solved. Let's code it up. Let's implement our two pointers method. So we want to create an array to return for answer. We need two pointers, one for marking the positive number and the other one for the negative number. We would like to initialize it. So we look for the first occurrence of the positive number. Just well and greater 0 because we will not encounter 0. So simply if the numbers p is less than 0, we don't want that, so we increment this. And then after these two loop, p is on the positive integer and n is on the negative integer. Then we want to write our array. Well, maybe this, and we maybe because the answer size is the same as the nums. And then we want the index to indicate the which entry we are writing. So we call it I, start from 0. And then when I less than m, it means we haven't finished writing. For each time we write one positive and one negative. Okay, then it's very simple. We so I equals to p, and then because after this we want to increment I to move on to the next entry to write, like this. And remember, positive p always mark the positive number, so we would like to move p. Well, p less than m, it means we don't want to let the index out of range. And the nums is almost similar, is similar to the previous here, but this time we have to check. Keep a plus. For the negative one, it's almost the same. Plus equals to numbers. And well, then less than n. Writing the k. And I think that's all. Let's run it. What happened? Okay. There's a we made a harmful mistake. Look at our output. What? We just print 3 minus negative 2, 3 negative 2? It seems like our pointers are not moving. And in fact, our pointers indeed not moving. Because, for example, positive pointers start from 3. And then, although we update I, it's the writer. But the P, because it's not less than 0, so it will not increment. So here we have to at least increment by 1, move up at least to next entry, but we don't know whether it's positive or negative. And so this is the negative one. And it should work. Yeah. Okay, submit it. Yeah, look at the runtime, although didn't beat 100%, but I think it's okay. Let's analyze the runtime and the memory. runtime is just O n, and is the size of nums, because we only go through the array once. It's better than the naive approach, which storing the positive and negative number into arrays. Because in that approach, we need to at least go through the array twice. Although they're both OM, but their constant term are different. And then we save a lot of memory because we only require, well, actually, because we have to return the answer, so it's also OM. So it's almost the same as the naive approach, but constantly better, like in constant terms. Okay, that's all. Yeah, it's an easy problem, and it, we can always optimize our naive approach. See you tomorrow.